Hello everyone, myself Sneha Shah from LG Institute of Engineering and Technology from the Department of Electronics and Communication Engineering. Today I am going to explain you from the subject Signal and System. The topic is classification of system from the unit Introduction to Signal and System. If we classify the system, first type of the system is linear and non-linear system. If we are defining the linear system will be defining as if any system follows the superposition principle, then it will be defining as linear system. Now what is the superposition principle? Function over a1 x1 of t plus a2 x2 of t will be defining as a1 y1 of t plus a2 y2 of t. Suppose if we are taking two signals x1 of t and x2 of t, and we will multiplying x1 of t with a1 and x2 of t will be multiplying with a. Now if you will adding this two signal, so after addition it will gives you the term as a1 x1 of t plus a2 x2 of t. Now on this if we are doing some function, so for that it will taking the system, so system's output will be y of t. So output of it will be same as the a1 y1 of t. It means first of all we are taking x1 of t, on that we will doing some operation by taking system, so it will gives you the output as y1 of t. Similarly we will taking the second signal as x2 of t, we will applying this in the system, so it will gives you the output as a y2 of t. Now if we will multiplying this y1 of t with a1 and y2 of t with a2, so the term will be a1 y1 of t plus a2 y2 of t. Now if we will adding these two terms, so output of this will be same as the output of this system. So this two will be same. If we will considering this, then this will be considered as the superposition principle. And if this two will be same, then this system will be defining as the linear system. Now the second type of system is non-linear system. Now what is non-linear system? If any system does not follow the superposition principle, then it will be defining as non-linear system. The next type of system is time invariant and time variant system. Time invariant system means it will delay or it will taking the shifting in the original input signal, then the same shift will be in the output signal, then it will be considered as time invariant system. So if we are defining the time invariant system, it will be defining as any system is considered as time invariant system if a time shift in the input signal will result in the same time shift in the output signal, so it will be considered as time invariant system. So what will be the condition for this? X of t will apply in the delay unit, so it will gives you the shift in the input signal, so the term will be x of t minus t. Now this will be applied to any system, so it will gives you the output of that system. This system will be same as if we will apply input to the any signal, so it will gives you the output, and then we will apply it to the delay unit, so it will gives you the delayed output. So if we are taking delay in the input or if we are taking the delay in output, so if this two will be same, then this kind of system will consider as time invariant system. Next type of system is time variant system. A system is said to be time variant system if a time shift in the input signal does not result in the corresponding same time shift in the output signal, then it is known as time variant system. Now the next type of system is causal or non-causal system. So first of all we are defining the causal system. What is causal system? A system is causal system if its output depends only on the present and past value of the input and it will not depend on the future value of input, then it will be considered as causal system. And if we are defining the non-causal system, then it will be defining as if any system output depending on the future value of input, then it will be considered as non-causal system. A system is non-causal if its output depends on the future value of the input, then it is considered as non-causal system. Now the next type of system is static or dynamic system. First of all, if we will defining the static system will be defining as any system output depend only on the present input. It will not depend on the past or future value of the input, then it will be considered as static or memoryless system because it will be depending only on the present value. So for the past value or for the future value, there is no requirement of memory element. So this kind of system is also considered as memoryless system. So static system will be defined as any system output at any instant of time depends on input sample at the same time. It means on the present time only, then it will be considered as static system. Dynamic system will be defining as if the system output depends on the input sample at the same time as well as on the other time instant also, then it will be considered as dynamic or with memory system, because for that the memory elements will be required to store the past value or for the future values. So dynamic system means it will include the present, past or the future values, then it will be considered as dynamic system. Now the next type of system is stable or unstable system. What is stable system? Stable system means a system is said to be BIBO stable, means bounded input, bounded output stable if it produces a bounded output for every bounded signal applied at its input. Means for every finite input, if its output is also finite, then it will be considered as bounded input, bounded output stable system. Now the next type of system is unstable system. A system is said to be BIBO unstable if it will produces the infinite output for the finite value of the input. It means unbounded output for every bounded signal applied at its input. Now the next type of system is invertible and non-invertible system. Now what is invertible system? If we'll applying any input to any system and it will be recovered back by applying output of it to the any another system, then it will be considered as invertible system. It means a system is said to be invertible if the input of the system can be recovered back from this system output. And if it will not recover back, then it will be considered as non-invertible system. So for the invertible system, suppose if you taking the input signal x of t and if you apply it to the any system, then it will give you the output as y of t, and if it will be applied to the any other system, so it will give you the output which will be same as original signal x of t. So this kind of system will be considered as invertible system, and the second system is inverse system of the first system. So if we are considering the example of this invertible system, then the first example is, suppose if we are taking any input signal and if we are applying it to the system in which we are doing the differentiation, then the inverse of the differentiation is integration, right? So in the inverse system we are taking the integration part, so it will give you the original signal back at the output side. So this kind of system is considered as invertible system. Now if we are doing the addition in the first system, then in the second inverse system we have to do the subtraction. So this way we can derive the invertible system. Means if we are taking the addition of two signal, or if we are taking the input signal and if we are adding some constant, then we have to subtract by the same factor in the inverse system to get the original signal back at the output side. So this way we can recover the original signal back. So this kind of system is considered as invertible system. Now the next type of system is non-invertible system. Now what is non-invertible system? Non-invertible system is defined as a system is said to be non-invertible if the input of any system cannot be recovered back from the system output, then it is known as non-invertible system. So in the today's session I had covered the topic classification of system. In this topic you had learned about the 6 different types of system. The first type of system is linear system. Linear system means if any system will follow the superposition principle, then it will consider as linear system. So for that, if you want to solve the example based on the linearity, then for that first of all we have to take input as a combination of two different inputs. Then we have to take output as a combination of two different outputs. And the equation of these two terms will be same, then it will be considered as linear. Otherwise, it will be considered as non-linear system. Then the second type of system is time invariant or time variant system. In this you had learned about that if the delay in the input signal will be same as the delay in the output signal, then it will be considered as time invariant system, right? So if you want to solve the example based on this, then you have to take delay in the input signal x, and then we have to take delay in the output signal y. And if these two signals will be seen, then it will be considered as time invariant system, otherwise it will be time varying system. Then the next type of system I had explained is causal system. Causal system means if the system depends on the present or past input, then it will be considered as causal system. So what will be the past? Suppose if I am taking the output on the 2 second, then for that on the 2 second input it will consider as present, and if we are taking the input on the 0 second or 1 second, then it will be considered as past input. So if this system will depending only on the present or past input, then it will consider as causal, otherwise it will consider as non-causal. Then next type of system I had explained is the static or dynamic. Static is also considered as memoryless, as it will not requiring any memory element. So it will depending only on the present input. Suppose if I am taking output on the 2 seconds, so for that the input requirement is only on the 2 seconds. On all the other terms will be considered as either past or it will be considered as future. So it will become under the dynamic type of system. Then the next type of system I had explained is the stable or non-stable or unstable system. So what is stable system? BIBO stable system means for that you have to solve the example as you have to take input as a finite. So for that the output should also be finite. So it will be considered as BIBO stable system. Otherwise it is considered as unstable system. And the last type, which one is invertible and non-invertible system. In this, if the system input we got back at the output side, so it will be considered as invertible system. Like suppose if I have given some example like integration differentiation, so by taking integration differentiation it will recover the original signal back, then it will be considered as invertible, otherwise it will be considered as non-invertible system. In the next session I will explain the example based on this. Thank you so much.